So for predicting double displacement reactions, right, remember there's three things we're looking for. Does it make a solid, right? So do some of the ions find each other, crash into each other, and crash out of solution? Do they make water, or do they make something that decomposes? And there's only one thing you have to memorize on the decompose, and that is hydrogen and carbonate. And hydrogen's +1 and carbonate's -2, so it's H2CO3. If you make hydrogen carbonate, there's a dash there, right? So hydrogen and carbonate is a dash. So that is something that decomposes. So this will decompose and not be hydrogen carbonate. That will be H2O and CO2. And you have seen that already a bunch of times. Anytime you put baking soda on an acid or something like that, you make it decomposes. It's the volcano kind of thing, right? So that's H2O and CO2. So you make a solid, you make water, or you make something decomposes. So when I look at these guys, it's positives attracted to negatives, negatives attracted to positives. So lead is going to try and get together with nitrate, and ammonium is going to try and get together with chloride, right? So pause the video and check your solubility chart. Are either of those any of those things, right? So I'm going to check lead with nitrate. I'm going to check ammonium with chloride. So pause the video and look ahead. So if we look at these two, I highlighted them on there for us. Our lead nitrate has a P for partially soluble, and our ammonium chloride has an S for soluble. So partially soluble, we're going to treat as insoluble. Now, realistically, how partially soluble it is, you'd have to have pretty good concentrations to get much precipitate there. But lead with nitrate. Now, lead, I can tell is a +2 because there's two chlorides here. So it's lead with a +2 charge. Nitrate, it's a -1 charge, so it's PbNO3 2. And since that's going to be a solid, for precipitate stuff, I like to use a down arrow because students will confuse the S for solid with S for solubility, right? So lead nitrate right there. And then ammonium with chloride, we said was soluble. Ammonium chloride is soluble there, so that's going to stay dissolved in water. So NH4, that's a +1. Cl is a -1, so it's just NH4Cl. Now, I know that you've got two nitrates and only one nitrate, so this isn't balanced. I'm not really worried about balancing right now. I can leave it as a skeleton equation, but we should make sure that we get the right formulas. If we wanted to come back and balance it later, we could, right? We erase any charges and stuff that we wrote so that we know we're looking at something decent there. So this would be the driving force of this reaction. This is what would cause it to happen, is forming this lead nitrate. Right, we look at another one down here, more of our lead chloride. This time, pause me a little earlier. Who are you going to compare? Who's going to try and get together with who? And then what are your solubilities going to be, right? Work ahead on me on this because this is stuff we should be able to do. So lead, you're going to compare to carbonate, and sodium, you're going to compare to chloride. So as we look at those, lead carbonate is partially soluble. For what it's worth, it is a lot less soluble than lead nitrate, but they've got that listed as a partially soluble. And sodium chloride, well, that's table salt. We kind of know that that is soluble, right? So the reaction will happen. We made something partially soluble or insoluble. So we'll put lead together with carbonate. Again, lead is +2 because the chloride is -1 and there's two of those. So lead must be +2. Carbonate, CO3, if you don't know the charge on that, that's going to be written right here on our list of polyatomic ions. Our carbonate is -2, so lead carbonate, and that's insoluble. So we would write an S or a down arrow to show that that's going to form a solid. And then sodium, we said got together with chloride. Now bring them across without their subscripts, right? Now the 3 is part of the carbonate, so I have to bring that 3 over, but this 2 doesn't get brought over. That's there because carbonate's -2. So the sodium comes over alone, the chloride comes over alone, and then they get together and form a new compound, right? So sodium with chloride, right? That's a +1 and a -1, so it's just NaCl, and that is aqueous 2. There's a lot to keep track of on each of these, right? Job number 1, figure out who you compare. Job number 2, compare them, see if you make something. Job number 3, bring them across. If you need to, if there's no reaction, you just say no reaction. If you need to, you bring them across and put together the right formulas, thinking about charges and stuff, right? So that's what this one would be. Again, we could deal with how many sodiums and chlorides there are if we wanted to balance it, right? So I could come back through and say, oh, well, this is an unbalanced equation. Well, now since I've got 2 sodiums and 2 chlorides, I can do that, and now it's balanced, right? So balancing is different than making sure you've got the right formulas. I don't care that there's 2 sodiums here. That's there because carbonate's -2. Over here, chloride's -1, so you only need one of them. Right? Hopefully that helps.